I am back. If you had attended some of my earlier lectures, you will notice that this is all a continuation of them. A lot of them are related to how to make prototypes and equipment like this. This is all electronic equipment, and then as I have pointed out earlier, making or designing electronics and making a breadboard is only a small part of the game. Finally, how well it fits with what the customer wants and little bit of, I will use the word marketability, is what the game is about. But then upfront one cannot commit the type of resources that are required to produce large electronic systems. That is where the concept of prototyping comes. This is, please have a look at it. This has been directly taken from Ulrich and Eppinger's book on concept generation, and then actually it is about product design and development. The idea is you buy the book, you benefit by it, and this is a little old, and if you see it is in fact almost 20 years old. So, I fully acknowledge the original authors and please buy the book. The starting point of any of these is, for example, if you look at this, somebody wanted to make a lamp, just about a lamp. There are two variants of the lamp here. See here, they are almost about the same, not too much different, is not it? Generically they are same because you can call this a table lamp. And then if you see here at the base, he has given a small keyhole like device. Yeah, at this point you can see that keyhole like thing. What this keyhole does is, here you can probably put it on a nail on the wall, and then you can use it as a, if it is here, no, you can use it for reading a book. Otherwise it stays here, and invariably all of them will have, this one has a small opening here for which we can charge it. So, this is an LED, I will say lamp, reading lamp, looks good enough. And the magic is, however, if you want to produce these parts in something for the market and something which does not exist, this is a slight improvement on that. Base is big, and if you see carefully, even this too has a small connector here at the corner. See here, small connector, and as before we have a lamp here, and maybe, so it is even working. Can you see? So, there is a small what do you call, I will say generically they are a little about a little same, and specifically there is a difference. You see here, for example, type of storage, the type of switch, this is a simple bistable or 2 position switch, while this one is the same 2 position switch, but a push button. Now, comes the question, let us say as a electronic engineer, you would like to now try to produce this and show somebody how your product is going to look like. Now, we come into the small problem. The other person does not know unless you show him this. In this case, while it looks simple enough, it is still expensive. We need to produce all these things. You understood, no? You need to produce all the base, you need to produce this, you need to produce this, and in some cases even a bit of optics is involved in it. So, there is an LED chip, then there is what you call a stem or a neck, it is called a gooseneck, I do not know why it is, and then you have this base, and then there is a sequence of assembly and disassembly. Now, even a simple thing like this, if it were to be made in plastic, is expensive, extremely expensive. It does not run into thousands. The mold which is used for making may cost a few lakhs, and if the market demands a large number, we need to make it on two things. First of all, scale up to large numbers. Secondly, maintain good quality. So, towards this, for maintaining good quality and large numbers, you need tooling, and if you want to do tooling, it is expensive, and first batch itself we cannot make expensive tooling. I will stop it there. These two, from an technical or what is a functional point of view, are a little similar. Both of them have a light source, both of them have themselves switching, and then there is a energy storage, except that this is a solar lamp which is built in. It is a standalone. You have a solar panel, then you have a front thing, and then there is a carrying thing. The idea is being you give it to a child, one lamp per child, just like you have one laptop per child, somebody gave it and then they distributed in schools. Now, the thing is, even this is expensive, it is not easy to make things. For example, you need to see how, you see here there is a solar lamp built inside. How are you going to manufacture it? Is it going to be one part, two part? If you examine it carefully, it is several parts put together. This is where the concept of prototyping comes. And then this lecture, let me now slowly lead to the thing. Loosely people have got used to the word 3D printing. It looks nice, everyone is familiar with the printer, and then if there is some way one can actually print objects, that will be a beauty. Conceptually it is very correct. Unfortunately, there is a little bit of hype which has been what do you call going around because of just like miracle cures and so on. No? We have so many cures, a lot of it is hype, and it will work only in certain specific conditions. This lecture is all about 3D printing for the purposes of making prototypes. And since we are an electronic design what do you call institution, lot of my examples and all are related to electronics design and enclosures. Small I would say, I will not call it warning, I have given you a hint already, saying the way things are, people keep claiming that even guns can be printed in 3D. True and not true also. A gun is not about a shape. If you just want a shape, if you want to make a toy gun, or if you want to make a gun which is used in this thing, then maybe yes it is. But then if you want something which is what do you call rugged and made in made something for a war, that is not the same gun, something of the same shape. Now we come to the other extreme, saying, sir, I have seen on the internet 3D printing demos of things like wall clocks, and I have been radio collared, except that I have been radio arrested. So, this one is a, I think you know what it is, activity monitor. Such things you can make them, yes you can print them, but this is not a cure all for everything. Again I am repeating, 3D printing is what it is. It can print a certain type of object for certain type of purposes. Something before 3D printing comes is how is your product going to be, what is the physical appearance of your product. Both are pocket hard disks. and first of all pocket friendly, not very expensive, maybe they cost around 3000 rupees, which is probably around $50, $50 to $100 you can get beautiful things. But you see here it does have certain features. First of all, it is a little flat, it is a box after all, and then other side you have all these things like this connectors, and you see here you have various types of connectors. And is it not the same as these things? You have seen that, no? I think you know what it is. It loosely we call it a thumb drive or USB stick and so on. Only common thing is we are all familiar with this stick. Now, the actual starting point of all these is how to generate a concept for your product. Just now I have shown you this, if I can see this display. Starting point is probably, you see, we have a large what do you call selection of things here. One of them in the selection of things is identifying customer needs. Seen there? Product specifications. After customer needs you have target specifications, then you have concepts, and then final specifications and all that. Here for convenience sake things have been made into neat small boxes and shown as a sequence. Usually it is not this over model, what you call over the wall design. Bottom you see here, build and test models and prototypes. This is where this rapid prototyping comes into the picture. Why it is called rapid prototyping is the very concept of any of this development process, you need to generate product concepts, select the concepts and test them like that. So, if you can make a proper prototype, you are already in, I should not use the word business, you are into it. It is tough. If you do not do it, you will end up with surprises in production. A few standard things, maybe I do not know, let us say even building a house or building furniture. If you are copying another piece of furniture or if you are copying another house, things are easy. Just go and tell the what you call the mason or anybody who does it. But then if you see carefully, architects have been extremely diligent and all that. They make a new instance of well known products all the time. So, prairie architecture and so on, same thing it is with our this thing. And for us to understand how your final product is going to look, we need to make a small prototype. So, in the concept development process, what could this be? It says it is a power nailer. Some of these you may have seen, the result of it you may have seen. The result of it is whenever they make or rather ship large items, they take a crate, and the crate at the base, you have the base which they try to build everything around it. They take the base, they keep the what you call your equipment on top of it, and all around they put various things, and at this point nails are fed and they keep coming out one after the other inside, and obviously it is run by air. So, if you see here we have so many of these things saying you make a external search, lead, experts, patents, literature, benchmarking, internal, group method, systematic, okay. Then clarify the problem, internally expose, because this is not about design as such. I will skip all these things. You see slowly things are getting interesting. I am sure you have seen most of these things, all of them you have seen, and it is unbelievable, is it not? No two of them are alike, and each of them is patentable, each of them is sold in large quantities, and this is where you need to come to prototype. Somebody after they have made this one or this one, they have to make a quick prototype. In this case it is not impossible, probably This is actually a plastic handle, this one is a wooden handle, and this is a what you call something which is made out of type of plastic which is mixed to that. This is again plastic. This one is a sheet metal which is folded like this, you see very carefully it is done, and this is again something else which is probably can be withdrawn. Now somebody needs to make a small prototype of it before they go into large production. So, I will go to the next slide where somebody needs to understand the voice of the customer. Valid, each one of the arguments is very valid, and this is where the actual concept of a prototype comes, saying something needs to be done so that the prototype I am looking for should be made quickly. You have seen this obviously, no, a minimum waste and saves time and all that. I will just skip all these things. This is related to a hammer. Okay. Since the concentration is not about how to come out with the solutions, but just saying why we need 3D printing and then why we need to be prototyping, I am just showing you these things. So, you see here so many of these things are there, saying go around search, find out what okay. This is the usual thing. So, at your leisure I suggest you buy the book and read it. After we go through the whole stage, you have seen this saying prototyping. Now, we come to two types of prototyping. One is we have gone through this all the thing including concept generation, selection and testing, and come to a prototyping. Another is this prototyping is needed at every stage. After integrate all these what you call specs and concepts, and then industrial design gives a proper trade off of it, saying what is it really that the customer wanted it, and then more important is you go up and down designing for manufacturing. At each stage you need prototypes. The prototype will help you in taking better decisions. So, we keep going on and so on and so on and so on. Prototyping is done throughout the development process, and this is where the whole concept of 3D printing really took off because of the sequential chain of events. You have seen here I have a huge chain of events and every stage takes time. So, there is no other way except what do you call this thing. I will come back, which I do all the time. You see here I wear this thing, I am sure some of you have seen these things. This is a hearing aid, and the difference being both of these look a little similar, except this one has a tip. This basic hearing aid is the same, this tip is different. This one has a molded insert. Seen this? Now, places like this, it is very much possible for us to make rapid prototyping. Now, I come to this thing, you see the small thing inside. I have a in the canal hearing aid, this directly goes into my canal. It is a beauty, you have seen this. So, and I have one for the right ear also, I have two of them, they happily go inside, you will not notice it that I am wearing it. So, such things you probably need prototyping, and in this case it is now possible for somebody to scan this. I just stand there, the whole thing is scanned, something can be made at the back, the form can be done, and even the canal can be scanned and things can be made here. Thing is, there is a little electronic, I am sorry, body or worn parts, little bit of thing is there. Now, coming back to my this thing, I have concept development, system level, detailed design, testing, refinement. At every stage I need to make prototypes. You have seen this at the concept development stage. I have shown you that we need to do system level design. System level design, immediately we do not talk about the actual physical thing. When it comes to detailed design and refinement, large number of prototypes are required quickly. This is where the concept of rapid prototyping started. So, in the case of rapid prototyping, we have the advantage of keep on making things quickly. You have seen here, taken as I said, taken with the due acknowledgements to Ulrich and Eppinger, and things have changed a lot, but you will never get a chance to see these things. If you see this, somebody has spent a lot of time in conceiving a product, and they have to make probably a few of these. This is where rapid prototyping actually meant a lot of advantage to everybody. What could be done was, very quickly people could come out with a model and print it and show it to others. It is not about showing to others, I will call it as evaluation. For the purposes of evaluation, while this looks okay, yes, in this lamps, each lamp looks okay, oh, I am here, okay. While this is okay, you will suddenly see, though this is bigger, somehow this looks more presentable, and it has so many other things. This is maybe a primitive earlier one, this is eventually something which can be used. That has become big because the storage has been changed. Now, coming back to my display here, in this prototyping example, now thing is, there is a small depression here, and then there is one what is equivalent to our what you call mouse key, then there is the trackball. All these concepts somebody needs to show and work. You have seen here, there is a switch. I am not sure what the switch is, but it is a switch, and this is a switch, this is a switch. So, if you go, this is where, allow me to spend a little bit of time here, so that when we actually get down to making a printed model, sometimes we forget, because we get caught in that whole thing saying, oh, wish we had thought about it, we have a model now, it looks like nobody wants it now. See this here, first thing is learning about the product or proof of concept model. So, it happens in all the time. Let us say at one extreme I showed you that one of the very simple thing, a potato peeler, and the other extreme we have things like a whole huge ship. A ship may be the final model and the prototype itself is the same, or you take a aircraft. A commercial aircraft, outside is all about aeronautics and everything, but inside design of the cabin is finally what the customer will see, and he will take a decision about to fly by it or not. So, building the interiors as a prototype is equally important. Now, in the interiors we are just generally familiar, there will be number of seats, a hill, commercial, and then so on, and then safety requirements saying where do you have emergency doors, and see all the small nitty-gritty details of the back of your seat next time when you go there. Somebody has thought about it. Now, how should the display look? How should be that portable table in which you place things? How do you put it? How is it anchored there? And even if the table is there, when the front seat person reclines, it should not change. And now, how do you lay out the things? We all have seen, we are all familiar with a small depression in a corner, so that you can keep a liquid cup and so on. So, these things can easily be demonstrated and so on. So, coming back to my display, you have seen this here, proof of concept also involves communication, demonstration of product for feedback. The designer has to get back both to the user and the manufacturer and other persons at all. Typically, a combination of such systems into the systems model. So, when you saw my hearing aid, what looks very simple is actually a very complicated things. It has 2 microphones, one for noise cancelling and one for direction. Then it has a 4 channel dynamic compounder. Then there is a switch in which I can select 4 programs, and there is a speaker, and of course, there is a power supply, and something which does not make sense to you if you are not hearing impaired like me, because you are born with it. These 2 ears, the phase of the signal is maintained by having a Bluetooth like device between the phases. So, if somebody talks a little far away, I mean, you can easily distinguish between these things. So, you see all this stuff now has to be integrated. You have seen this, no? Combination of subsystems into systems model, and alpha or beta test models. Alpha is actually you start the things and see how well they work. Beta is finally just before release, you give it to actual users, volunteers, and then they make it. Otherwise, you will not be having so many beautiful daily gadgets which you have. And you see here, as we go down, goal for development team schedule, first testable hardware. Before we get to this, if you want to integrate something into anything, now have a look at this mouse. I am sure if you have a look at this mouse, you will see how well things have been integrated into it. The next slide, you have seen this types of prototypes: physical, analytical, comprehensive. What somebody would want is a final product having all the necessary physical features, and we are ready, and some needs to go into all these things. So, if you go to an engineering school, when you talk about modeling, invariably they talk about analytical modeling, saying how well you have understood flow of water, flow of steam, and in the case of extremely large system, how the atmosphere can be modeled into an equation like that. That is fully analytical. And you see here focused what you call prototype, saying one particular type of operation, when you want to make a switch, how much effort is needed to push it, and finally how big things are able to make. So, here physical comprehensive involves all the things, okay, and comprehensive analytical is not easy. Even in the case of our electronics, we all know mixed mode simulation has come about, meaning a majority of all the parasitics, including both digital, then the analog, has all been dealt with. But when it comes to those things being put into a enclosure, and these days if you take any small mobile phone, it has 6 radios and attendant antennas, and as if it were not enough, we also have accelerometers, and all of them are happily integrated into that. This is where prototypes need to be built. So, this lecture permit me to talk a little more about this stuff.